All right, looking at solving one-step equations with multiplication and division. So just from yesterday, we were doing it with addition and subtraction, where we use the additive inverse. So the additive inverse of whatever you're adding or subtracting is just the opposite. So here on this one, you'd minus 3457. And what you do to one side, you do to the other, because this is an equation that's balanced. And so we have to keep it balanced. Okay, and once again, the reason for doing this is to isolate the variable so we know what the variable equals. Okay, so then you're left with x equals, then you've got 84.76 minus 34.57. That's going to leave you with 50.19. All right, likewise on this one, x plus 17.5. So the inverse, additive inverse of the plus 17.5, once again would be a minus. So you're minusing 17.5 from both sides. Okay, what happens here is those cancel out. Once again, leaving you with x, and then 8.4 minus 17.5 is going to give us a negative 9.1. All right, so that was yesterday. However, the steps are going to be the same, except instead of additive inverse, we're going to be looking at the multiplicative inverse. So we're looking at the multiplicative inverse of the coefficient. So the coefficient is the number that is in front of the variable that you are multiplying the variable by. Okay, so the multiplicative, so if you had 5 as the coefficient, the multiplicative inverse, or the reciprocal of 5, the number that you multiply 5 by to get 1 would be 1/5. So of this coefficient 5, the multiplicative inverse is 1/5. Okay, so that's going to give us 1. And I'll explain that here in a second, why we're trying to get to 1. So multiplication and division are inverses of each other. We will be using the inverse operation to solve for the variable. So this is what we're going to be doing. We're going to be taking the multiplicative inverse and applying that to both sides of the equation. 1, because it's going to isolate the variable. So just like up here with 34 minus 57, sorry, 34.57 minus 34.57. What this did was got rid of the constant and leaving us with the x, so isolate the x. Because in addition, anything you add 0 to is just going to be itself, so x plus 0 is x. Likewise with multiplication, the number you multiply a number by to keep it the same is 1. So what we're doing here is this 6 times x, we're getting rid of the 6 and turning it into 1 by multiplying it by its multiplicative inverse. Okay, so 6x equals 12. First step is to isolate the variable using the multiplicative inverse of the coefficient. So, well, that is 1/6. Well, multiplying by 1/6 is the same as dividing by 6. Okay, the 6 divided by 6 cancels out to 1, and 1 times x is just x. So we've isolated the variable on the one side. We've multiplied both sides by the multiplicative inverse to keep the equation equal. What you do to one side, you have to do to the other. So now you have 12 divided by 6, and that gives you 2. So there we've solved for our x. Okay, likewise over here, you've got x divided by 12 equals 7. The multiplicative inverse coefficient, which the coefficient here would be 1/12. Dividing by 12 is the same as multiplying by 1/12. And so then the coefficient is 12. So we're going to, or the multiplicative inverse is 12. So we're going to multiply both those by 12. What we do to one side, we have to do to the other. So over here, 12 times x divided by 12 just leaves us with x. We've isolated the variable. We got rid of the coefficient. Okay, then on the other side, we're going to be left with 84. So once again, isolate the variable with the multiplicative inverse. Apply that multiplicative inverse to both sides. Okay, next one here, x divided by 4 equals 2. So once again, that's actually x times 1/4. The multiplicative inverse of that is going to be 4. Okay, this is going to isolate the variable, leaving us with just x. Okay, and then on the other side, 2 times 4 is 8. right, negative 5x equals 75. So here our coefficient is negative 5. The multiplicative inverse is 1/5, or is a negative 1/5. So we're going to multiply that by a negative 1/5, which is the same as dividing by a negative 5. Once again, those cancel out, and a negative divided by a negative is a positive. So that gives us a positive 1x. Okay, what we do to the one side, we have to do to the other. So we're going to divide this side by negative 5, which is the same as multiplying it by a negative 1/5. When you do that, you get a negative 15. Okay, so make sure we're following the steps for multiplying and dividing integers. Okay. Now this one might seem a little tricky. There's no number in front of x, but whenever there's no number in front of a variable, that means that there's always one present. We just don't usually show that. So if this is a negative 1 times x, the multiplicative inverse of that would be negative 1. Or dividing by a negative 1. So we're going to divide this by a negative 1, divide this by a negative 1. That's going to cancel out the negative, leaving us with a positive x. And then 10 divided by negative 1, it's just going to turn that to a negative 10. Okay, and last one here, x divided by 9, or x times 1/9. Apply the multiplicative inverse to both sides. This is going to cancel out, leaving us with x. We've got 45 on the other side. And what you'll notice here, really what we're doing, is if the coefficient is in front of the variable, you're going to divide the right side by what that is. I'm going through the steps to just show this is why it works that way. But noting that, okay, if it's a 5x, you're going to divide by 5. Or on these other ones, if it's an x over 4 or an x over 9, you're going to multiply the other side by that number you're dividing the variable by. Okay, so think of it, this is division, x divided by 9. To undo that, you multiply by 9. This is 5 times, or negative 5 times x. To undo that multiplication, you divide by that value. Okay, last thing we want to look at here is writing equations for one-step equations here, and then also solving. So here it says Tommy has $45 to spend on his friends. For gifts, he buys 3 friends the same shirt and uses all his money. How much did each shirt cost? So here we assume it's the same shirt, so it should be the same price. Well, on one side of the equation, we know 45 is the total amount of money he spent. We have the x, this is going to equal the value of the shirt. And he bought 3 of them, so you times that number, that cost by 3, and you get 45. So this would be the equation, 45 equals 3x. And if you want to label this as $45. So now to solve, we're multiplying by 3, so to undo that multiplication, we divide by 3. Okay. And this is going to leave us with $15. And then over here, we're just left with x. So the cost of the shirt was $15. All right, and one last one. So 4 friends went to dinner and split the check evenly. If each person paid $13.50, what was the total cost of the dinner? So we'll set up the equation. $13.50 is equal to, so x in this case is the total cost. Okay, and $13.50 is what each person paid, and that was 4 people that paid that. So what they did is they took the total cost and divided it by the number of people that ate. So x divided by 4 equals $13.50. Right, so once again, this is our equation. This is how it should be written out. And some of you might say, well, you just take $13.50 times 4 to get the total cost, which is what we're going to do here. but it's important to see how you can set up those equations. And moving forward, if you think about coding, right, you need to know what to tell the program to do, and if you don't use the right equation, you're not going to get the right results. Okay, so then here to solve it, multiplicative inverse of 1/4 is 4. So we're going to multiply both sides by 4. That's going to kick out, or leave us with x is equal to $54. And that is using solving one-step equations with multiplication or division.